Hello friends, welcome back in this video lecture of refrigeration and air conditioning subject. We will start unit number 4, refrigerant used in vapor compression refrigeration system. My name is Mr. S. V. Kumbar, Assistant Professor, Sharad Institute of Technology, College of Engineering, Yadra, Ichalkaranji. So we'll start with definition of refrigerant. So what is a refrigerant? Refrigerants are the working fluids in the refrigeration and air conditioning as well as heat pump system. They absorb heat from one area such as air conditioning space and reject it into another area such as outdoor, usually through evaporation and condensation respectively. So refrigerant is a medium of heat transfer in refrigeration and air conditioning. So latent heat of vaporization plays very important role in case of refrigeration and air conditioning. So how refrigerant works? With the help of this figure, we will see how refrigerant works. So first of all, in the compressor, hermetically sealed compressor is used where vapors of refrigerants are compressed, due to which it is converted into high pressure high temperature vapors. This high pressure, high temperature vapors of refrigerant, it then flows through condenser coil where heat energy is rejected from refrigerant in the condenser. Now generally we use either air or water as a cooling medium. Now as heat is rejected in the condenser, it is converted into high pressure, low temperature liquid refrigerant. So phase change takes place in condenser. It is converted into liquid. This high pressure, low temperature liquid is sent to metering device or it is stored temporarily, and after this it flows through expansion valve where sudden expansion takes place, because of which its pressure drops down. So this color represents its expansion line, and here it expands inside the expansion wall. Pressure decreases suddenly, and here low pressure low temperature liquid refrigerant finally flows through evaporator coil where the object which is to be cooled is placed. Now this evaporator is a deep freezer in refrigeration space, or in case of air conditioning, if you pass air over this evaporator, then it becomes cool, and this cooled conditioned air is sent back to the room itself. Now due to absorption of heat here from the object which is to be cooled, it is converted into low pressure vapors, and this low pressure vapors is sent back to the compressor, and in this way refrigerant works. So if you observe carefully, in the condenser heat is rejected from the refrigerant, and in case of evaporator heat is absorbed from object which is to be cooled by this refrigerant, liquid refrigerant. So history of refrigeration. So refrigerant, first generation refrigerant was ether, carbon dioxide, ammonia, sulfur dioxide in 1830. But as the time progresses, in the second generation in 1930, HC, that is hydrocarbons, ammonia and water was used as a refrigerant. After that, in the third generation, CFC, that is chlorofluorocarbon, HFC, ammonia, water was used as refrigerant. But after Montreal Protocol in 1987, some refrigerants are outdated. And after this, in fourth generation refrigeration, after Kyoto Protocol 1997, some refrigerants are banned, and nowadays after 2010 we are using only hydrocarbons, hydrofluorocarbons, then carbon dioxide, ammonia, water as refrigerant. So still research is going on to use effective refrigerant in refrigeration and air conditioning system. So here in 1834, invention of vapor compression process with natural refrigerant. In 1834, carbon dioxide, ammonia, hydrocarbons, that is natural refrigerants were used. In 1930, invention of safety refrigerant, that is 1930 to 1950, CFCs, that is chlorofluorocarbons were used. And after that, in 1980, HCFCs were used. And after Montreal as well as Kyoto Protocol, some refrigerants are banned and HFCs were used. And nowadays in 2020 we are using carbon dioxide, ammonia, hydrocarbon. These are the natural refrigerants which are having low GWP and ODP. Classification of refrigerant. Generally refrigerants are classified as primary refrigerant, which can be directly used for the purpose of refrigerant. If the refrigerant is allowed to flow freely into the space to be refrigerated and there is no danger of possible harm to human being, then primary refrigerants are used. The refrigerant used in domestic refrigerator, that is Freon 134A, these are considered as primary refrigerant. Secondary refrigerant. The refrigerants, that is brine, water plus salt solution, which is used as an intermediate fluid between evaporator and substance to be cooled, is called as secondary refrigerant. So they don't directly take part in the refrigeration because it is the medium between evaporator and the substance to be cooled. They cool the substance and space by absorbing their sensible heat. These are also called as indirect expansion system. For example, brine solution made of calcium chloride or sodium chloride, which is generally used for storing ice cream purpose. You might have eaten ice cream, so for that purpose brine solution is used. Water cannot be used as secondary refrigerant because at 0 degree centigrade itself it will become an ice and circulation of ice is not possible. That's why calcium chloride or sodium chloride is much preferred in water, but it is very costly. Calcium chloride is very costly, so that's why NaCl, sodium chloride, is used in water to act as a brine solution. Substances that take away heat from the medium to be cooled and give it to the boiling refrigerant are called as secondary refrigerant. They do not change their physical condition. Desirable properties of a good refrigerant. First, thermodynamic properties. First one, low boiling point. The refrigerant which is used must have low boiling point, generally in minus. For example, ammonia. The boiling point of ammonia is minus 33.33 degrees centigrade. So, as atmospheric temperature is in between 25 to 30 degrees centigrade, at atmospheric condition, ammonia is available in vapor. Second important thermodynamic property is low freezing point. The refrigerant which is used must have low freezing point. Otherwise, if its freezing point is high, then it may choke in the suction or discharge lines. Third important property, positive gauge pressure in the condenser and evaporator must not be very high. Fourth, high latent heat of vaporization, which is very important property of refrigerant. Here it must absorb or reject high latent heat of vaporization. Some chemical properties are, it must be non-toxic, non-flammable, non-corrosive, chemically stable. The refrigerant which is used must be non-toxic. In case of leakage, if refrigerant escapes from the refrigeration system, it should not affect to human life. Second, non-inflammable means it should not catch fire as soon as it comes in contact with fire hazards, as well as it should not be non-explosive in nature. Third important chemical property is non-corrosiveness. It should not corrode to the metal through which it is flowing, otherwise its life will be affected. Fourth, chemically stable means if in case oil gets mixed with refrigerant, its chemical composition should not change. Thermodynamic properties of refrigerant: boiling and condensation temperature and pressure. The boiling temperature of refrigerant at atmospheric pressure should be as low as possible. The evaporator and condensing temperature determines the pressure. The maximum condensing temperature is largely affected by climatic condition, because generally condenser is exposed to atmosphere. So as climate condition changes, again its condenser temperature changes. It is desirable to select a refrigerant whose saturation pressure, that is at minimum operating temperature, is a few pounds above atmospheric pressure. If the boiling temperature of refrigerant is high at atmospheric pressure, then compressor has to operate at high vacuum. Both evaporator and condenser pressure should be positive and it should be near to atmospheric pressure. These are the thermodynamic properties of refrigerant. Few chemical properties that we had already discussed. Toxicity: the refrigerant which is used should not be toxic in nature, but ammonia is toxic in nature. Ammonia is considered as poisonous. In case of leakage, it may harm to human life. Flammability: refrigerant should be inflammable, but the ammonia is flammable. So that's why while using ammonia, we have to handle that refrigerant very carefully. Action with oil, as I discussed, in case of miscibility action, it should not miscible fully with refrigerant, that is oil should not be mixed, and even if it get mixed, then its chemical composition should not change. So R12 R11 does not create any problem for any action with oil. Economic properties: the refrigerant which is used preferably inexpensive and easily available here near to our area. Otherwise, in case of leakage, we have to purchase it from some other countries or some other area, and it may take long time. That's why it is easily available and inexpensive in nature. Another important property in case of leak detection: if there is a leakage in case of refrigeration system, the leak detection test should be very easy. One example is given here: vacuum leak test. We can use leaks may be detected by either pressurizing the system and checking for leak to the outside, or by drawing a partial vacuum in the system and then checking for rise in pressure on a test gauge. The vacuum method can indicate if there is a leak but not where it is located. A vacuum leak test normally performed after pressure testing and repair of leak has been completed as final check. So sometimes soap bubble test is also used to locate where is the leak problem. So location can be easily detected with the help of soap test. Next one, inorganic compounds. The refrigerant under inorganic compound group were universally used for all the purposes before introduction of halocarbon group. They are still used for different purposes due to their inherent thermodynamic and physical properties. Some inorganic compounds are R717 ammonia, R118 water, R729 air, R744 carbon dioxide, R764 sulfur dioxide, NH3 ammonia, that is ice plant, which is used in ice plant. Then water is used as refrigerant in water absorption refrigeration system. Air can be used as refrigerant in aeroplane refrigeration system. Carbon dioxide can be used in ship refrigeration system. Halocarbon compounds. This group of refrigerant was invented and developed by Charles Kettering and Dr. Thomas Migley in 1928. These refrigerants are sold in the market under the trade name as Freon, Genetron, Isotron, and Arcton. It includes refrigerant which contain one or more three halogen, chlorine, fluorine, and bromine. The most of the refrigerant used for domestic, commercial, and industrial purposes are selected from this group due to their outstanding advantages over the refrigerant from other group. The list of halocarbon refrigerant commonly used is given below with their chemical formulae. This is the list. R11 trichloro monofluoromethane. Its chemical formula is also given. CCl3F. R12 dichloro difluoromethane. R13 monochloro trifluoromethane. R21 dichloro monofluoromethane. R22 monochloro difluoromethane. R30 methylene chloride. R40 methyl chloride. R100 ethyl chloride. R113 trichloro trifluoroethane. R114 tetrafluoro dichloroethane. R114A dichloro tetrafluoroethane and R115 difluoroethane. So this is the name of refrigerants which are generally used nowadays. Hydrocarbons. Most of organic compounds are considered as a refrigerant under this group. So it contains hydrogen and carbons. But many hydrocarbons are successfully used as a refrigerant in industrial and commercial installation. Most of them possesses satisfactory thermodynamic properties, but because of its highly inflammable in nature, generally they are not preferred, but still few refrigerants are used in refrigeration and air conditioning, that is R50 methane, R100 ethane, R290 propane. Azeotropes. The refrigerants under this group consist of mixture of different refrigerant which do not separate into their components with the change in pressure or temperature or both. They have fixed thermodynamic properties. Next point is refrigeration designation. So all the refrigerants are designed by R followed by a unique number. As I already told you, R717, R12, R100, R114. So R represents a refrigerant followed by a unique number. Fully saturated halogenated compounds. The refrigerants are derived from alkanes, that is CN, H2N plus 2, such as methane, ethane, etc. The refrigerant are designed as RXYZ, where X plus 1 indicates the number of carbon atoms, Y minus 1 indicates number of hydrogen atoms, and Z indicates the number of fluorine atoms. The balance indicates the number of chlorine atoms. Only 2-digit indicates the value of X is 0. For example, R12. It means that the value of X is 0. Means the value of carbon is absent. Natural refrigerants. The chemicals which occur in nature due to biological or chemical processes are known as natural refrigerants. Natural refrigerants can be used as cooling agent in refrigerator and air conditioning. These do not deplete the ozone layer and make negligible contribution to global warming. Generally, natural refrigerants have high efficiency, that is, lower indirect contribution to global warming than many fluorocarbons. Generally, we use water, carbon dioxide. These are natural refrigerants. Now, why to go for natural refrigerant? Because natural refrigerant deliver on the Montreal and Kyoto protocol. Natural refrigerant have no or very low GWP, that is global warming potential. But carbon dioxide has more global warming potential, zero ozone depleting potential ODP, which was discussed in Montreal protocol, and reduction of CO2 equivalent emissions was discussed in Kyoto protocols. So some refrigerants are banned in that protocol. Applications and limitations. Ammonia. Generally, ammonia is used in large air conditioning system, that is in chillers, commercial and industrial refrigeration, that is storage of food, brewing, heat extraction, ice ring, etc. And limitation of ammonia is it is ideal and efficient refrigerant if used in accordance with national safety standards and code practice, as ammonia is flammable in nature. Second, carbon dioxide. Generally, carbon dioxide is used in static or mobile air conditioning system, warehousing, commercial refrigeration, chill cabinets, vending machine, process chilling, low and ultra low temperature applications. But the limitation of carbon dioxide, if it is used as secondary refrigerant along with ammonia, thereby opening application where ammonia as a single stage refrigerant would not be applicable, as well as carbon dioxide creates problem like global warming. Hydrocarbon refrigerant. Generally, these are used in industrial and domestic air conditioning, domestic appliances, commercial and industrial refrigeration, chill cabinets, vending machine, heat pump, low and ultra temperature application. But due to extremely inflammable, they can be used for other purposes also. Benefits. Regulatory compliance. In many countries, the use of availability of HCFC and HFCs are controlled by legislation due to their environmental impact. In Montreal Protocol or Kyoto Protocol or other related local environmental legislation, few refrigerants are banned. Low environmental impact. They have zero ozone depletion potential and minimal GWP. In comparison, commonly used HCFC, hydrochlorofluorocarbon, and hydrofluorocarbon have a GDP varying from 100 to 1000. High performance. The refrigerant should have high thermal performance, that is excellent thermodynamic property. Cost competitiveness. Use of natural refrigerant generally lead to lowering operating cost due to less leakage, lower maintenance requirement and better energy efficiency. And last one, compatibility. Natural refrigerant work well with commonly used oil and fluid. So this is all about today's lecture. Thank you very much.